Okay, in this section we have indices or powers, and we need to just explore what the rules would be connected with those indices. So for example, if you have 3 to the power of 2 times 3 to the power of 4, well, that 3 to the power of 2 means that there are 2 3's multiplied together like this, and the 3 to the power of 4 means there are 4 3's multiplied together. So altogether that would be 6 3's multiplied together. So the rule is that you can just add the exponents, the 2 and the 4 together to give 6. If you write that down in a rule, it's going to be a to the power of m times a to the power of n equals a to the power of the two things added together. And a similar kind of thing works for the division, except in this case you have the numbers cancelling each other out, so it's m minus n instead. You can see in this next one, if you've got 5 squared to the power of 3, that means 5 squared times 5 squared times 5 squared. If you add the 2 and the 2 and the 2, that's the same as multiplying 2 times 3, which is why we have, in this case here, a to the power of m times n up there. In the next one, we have, whenever you have it to the power of 0, that's always going to be equal to 1, because, for example, 7 squared divided by 7 squared, well, it has to be 7 to the power of 0, because 2 minus 2 is 0. But any number divided by itself is just 1. So 7 to the power of 0 is equal to 1. A to the power of 0 is also going to be 1. Now just continuing on a little bit. If you have negative powers, and this is something that often confuses people, if you have negative powers, it's the same as having 1 over whatever the positive power would be. You can see here that 1 over 6 to the power of 3 is like 6 to the power of 0 divided by 6 to the power of 3. So it would be 6 to the power of 0 minus 3. So it makes sense for 6 to the power of negative 3 to be the same as 1 over 6 to the power of 3. So more generally, if you have a to the power of minus n, that's just the same as having 1 over a to the power of n. And very, very quickly, the other examples that we have here, whenever you've got 2 times 3 to the power of 3, you can just effectively you can distribute the 3. You do 2 to the power of 3 and 3 to the power of 3, multiplied together. So that gives you, in this case here, a to the power of n times b to the power of n. Similar kind of thing happens with division. If you've got a fraction to the power of a negative number, the easiest thing to do is to flip the fraction upside down and make the negative number positive. And you can distribute it like that. And then this last example, if you've got the top being raised to a negative power and the bottom being raised to a negative power, then it's easy to just flip both of those things upside down and make them positive instead. If you haven't already tried these examples on the second page, you should try them now. Give yourself perhaps 10 minutes to try to simplify each of these expressions as far as possible, and then come back to the video. So you can just check for yourself. Then the rest of this sheet is just an explanation of roots, starting with square root. Basically, the square root of a number is the number which, when squared, gives you the original number. So the square root of 16 is 4. Notice that it's got to be positive 4, it can't be negative 4. And one interesting thing is that you can't take the square root of a negative number. It's not possible, or you don't get what we call a real number by doing so. There's no number that when you square it gives negative 4. Now on this last page, going to the top of the last page, you'll notice that there are some numbers, for example 1, 4, 9, 16, 25, etc., that when you do the square root you have nice numbers as your answer, but most of the time you get something that's approximate from your calculator. So if you're asked for an exact answer, you should leave it as square root of 5, for example. Now anything that's written with a square root or a cube root or anything that has this symbol in it is called a radical or a surd. Now there are other roots. The cube root is written like this, and if you're thinking of the cube root of 8, you're looking for a number that when you multiply it by itself and by itself again gives you 8. In the same way, cube root of 27 is 3, because 3 times 3 times 3 is 27. There's something similar with the fourth root. The fourth root of 81 is 3, because 3 times 3 times 3 times 3, 4 of them multiplied together, gives you 81. Now, this last thing, this thing right down at the bottom, is just pointing out a little danger that we have. If you're taking, for example, the fourth root of negative 2 to the power of 4 down here, usually you would imagine that the fourth root of negative 2 to the power of 4 would be negative 2, because the nth root and the power to the power of n are kind of the opposites of each other. However, if it's an even root, like the fourth root, and an even power, well, negative 2 to the power of 4 is actually positive 16. And if you're looking for the fourth root of a positive number, the answer is going to be positive. So the fourth root of negative 2 to the power of 4 is a positive number. It's actually the absolute value of negative 2.